What we have here is question 10, okay? Now, it says the triangle ABC, which is a triangle with three vertices ABC. It says the angle ABC is 90 degrees. When you see this, it's the middle letter that is the most important. That means that this angle of B is located here. Okay, that's the 90 degree one. AB, which is A linking to B, is worth 2. B linking to C is worth 1.5. Find the value of AC. If it's a right angle triangle, you're always allowed to do Pythagoras' theorem. So we call this X. So what should I write in for Pythagoras' theorem, Mick?
2 for the first one.
2 is not the longest by eyesight.
Oh, okay, well, X.
Yeah.
If it's like very close and you can't really tell by eyesight.
It's always the, see the right angle?
Yeah.
It's always the one that the right angle is looking at.
And does that mean X is still the hypotenuse? Or
X is the hypotenuse, yeah.
Okay, yeah.
It's technically opposite to 90 degrees,
yes.
but it's anything, if it's opposite to 90 degrees, it's the hypotenuse. Okay. What's next? What's next?
2 squared and
yeah. 1.5 squared, alright. So x squared equals 4 plus 1.5 squared is 2.25, and then x squared equals 6.25. Square root it, and what happens?
3.1.
It's going to be what height?
3.125.
No, 2.5.
2.5. Okay. Shh. Now lads, we know that's 2.5. The next thing we have to do is we have to find out the angle BAC. BAC is this angle here. B going to A on to C. So let's just call it our own letter. Yes, Sean?
I got 502. Is that the same thing?
Yes, it is the same thing. If you press the change button in your calculator, it'll change 5/2 to 2.5. Okay, we call this angle. We'll call it angle M. Okay. Shh. Now we're gonna. What? Do you remember the letters, the sequence of letters?
Yeah.
So could do
Yeah. S O H.
Yeah.
C A H T O A.
Which one should I use? I'm gonna use the 1.5 and the 2.
The adjacent and the opposite.
Yeah. Which is tan. Okay, so tan what, Mick? What did I label the angle?
Me?
Yeah.
Oh, tan
It's an M, sorry, it's a poorly produced M.
Equals 2. Do you do the longest?
Opposite over adjacent.
Oh, sorry, 1.5 over 2.
1.5 over 2. How do you separate, Dennis, how do you separate tan and M from each other?
You put the tan in the first.
And what does it change into? It's a button on your calculator.
Oh, it's a -1.
Tan inverse is what it's called, okay?
Yeah.
So you get your calculator out, and then you do shift tan inverse. Press the fraction button first. 1.5 all over 2. Make sure it says D up there. And you get 36.87 to the nearest degree. 37 degrees. Many people got that. Okay, the majority of the class. Number 10. Okay, now 12 is quite hard as well. 12, we have a right angle triangle. So we don't want that. That's good. So here's 12 here. One of them's 16, the other one's 30. Can anybody tell me how to get AD? This one here.
Use minus the hypotenuse.
Write down the triangle that has the most information. The triangle with the most information is the small one to the right.
The adjacent.
30, 16. Yeah, you have to.
Adjacent and the opposite.
Yeah. And we would have to find out the hypotenuse. Any idea how to find out the hypotenuse?
Do the brackets.
Yeah, Pythagoras' theorem it's called, okay? So, which one comes first?
30 or X.
Yeah, because it's opposite the 90 degree angle. 16 squared plus 30 squared, x squared equals
Should not be 30 squared plus 16.
Same thing.
Yeah, obviously.
What is it, guys? So it's 900 plus 256, and x squared equals 1156. What's the square root of that? 34. So x equals 34. Now that we know that much,
That means the other line is 34.
see these two lines here?
So this one's not.
These two lines means that they're equal to each other. So they use a marking to show that when two lines are the same. So that means this one is also 34. And that means that B to C is what length now?
Sorry?
30 plus 34 is 64, yes, Sean?
I don't understand how you know the other one's 34 as well.
See, if I do this to a triangle, Sean, if I do that, it means automatically they're the same length. If I do this, they're the same length. It's just a signal to say they're the same length.
Yeah.
Okay, find the angle ACB. What triangle does ACB belong in? Well, it technically belongs in two triangles, but only one of them is a right angle. Which triangles does ACB belong in? The angle ACB. This angle here. The big one is a right angle triangle, so it's the correct choice, right? So Paddy, look at this.
The left or right angle triangle now?
This one here?
Yeah.
No, because this angle is not 90 degrees. It's bigger than 90 degrees.
Yeah.
So, will you tell me how to do this one here? ACB. We're finding out this angle here. Yeah.
Do a tan.
What length is this one here? AB.
16.
And BC.
64.
64, right? And what letter do you want to call the angle?
P.
A. Okay. It is AC, yeah, go for it.
What am I wondering?
You want to find the value of the angle.
Oh, the angle.
Yeah.
Oh, yeah, so tan.
Yeah.
Inverse.
Just tan P equals 16 over 64, and then you brought the tan over the other side.
Yeah, so tan inverse.
Tan inverse
16 divided by
64, and what do we get?
14 degrees.
14 degrees. How many people got 14 degrees? Well done.
So where'd you get the 64 from?
See this one here, Sean? That's 34. And 34 plus the 30 gives me 64.
Okay.
Because it's the same length as this one. This one's 34 as well.
Yes.
They're the same length as each other. Okay, guys.
Great.